I got water in my hand right now.
Okay, so what we're dealing with is the ability to graph polynomial functions and then write polynomial functions of least degree from the graphs. Now, when we are graphing, in order to graph, there are 4 things that we've got to be able to do. We must have the zeros, number 1. But good for you, I'm not going to force you to find the zeros and then graph them. I'm going to go ahead and tell you what the zeros are or tell you what the factors are. Number 2, you must have the leading coefficient sign. Number 3, you must understand how multiplicity affects the graph. And number 4, you must understand how degree and sign of a leading coefficient affects the graph. Now, earlier we talked about multiplicity, but I'm going to restate it. Multiplicity is the number of times that a zero occurs. We know that if our multiplicity is 1, that means that that zero occurs 1 time. It's like a linear expression or linear graph. When I graph it, the graph passes directly through the 0, just like a line does. For multiplicity 2, this is when we have 2 of that 0. It's like a quadratic function. The graph does not pass through the 0 and therefore looks like a parabola. Multiplicity 3 is cubic. The graph twists through the 0 like a cubic function does. And for your and my benefit, if you're not good at drawing a cubic function, put a little squiggly in the middle and I'll know that you mean that it's a cubic function. Now, these are the 3 ways that we can graph through a point. Okay? If we get higher degree polynomials or higher degree multiplicity, there aren't other ways to do it. So, anytime your exponent is even, it's going to look like a quadratic. Anytime your exponent is odd past 3, it's going to look like a cubic. Okay, the next thing is the leading coefficient, sign, and degree. So, let's copy this down, and then we'll discuss it. Okay, so the leading coefficient, sign, determines the direction of the polynomial, of the direction of the graph. The degree determines whether both ends are the same or opposite directions. So if you have odd degree along with a positive leading coefficient, then your directions are going to be opposite like this. In other words, up to the right, down to the left. Notice I left some space in between these little arrows because there's a lot of stuff that could be going on in between. So they're doing opposite directions, but one goes for a positive leading coefficient, up to the right, down to the left. For a negative leading coefficient, it's going to be up to the left, down to the right, just the opposite. If your degree is even, you're going to be moving in the same direction with your arrows. If it's positive leading coefficient, both sides are up. If it's a negative leading coefficient, both sides are down. All this is really important information when it comes to graphing these things. Polynomials. Okay, so in looking at our graph again, we need to fill in some of the unknown things that we have not done yet. All right, in number 1, we said that it was second degree, and our leading coefficient is positive. So what does that tell us? Both sides up. Okay? So, when I graph these things, all you're going to do is put a point on the x-axis about where it would be. In other words, -1, that's to the left. -1. +2, that's to the right of 0. Is my scale this consistent, or am I proportional, or do I even have any scale or anything on here? No, this is a sketch. A sketch is a sketch. It's not perfect. So we know that both ends are going to go up. Both ends are going to be ending up facing up. But we need to look at the multiplicity of each of those points. Of each of these points, our multiplicity is 1. So what does that mean? That the line or the curve goes straight through each of those points. So I know that I'm going to finish up, and I'm going to finish up, and I had to go straight through those points. Now, in order to connect my curve, I got to curve around, okay? So I just make a parabola. Is that parabola drawn perfectly? No, it doesn't matter. It shows me what I need it to show me when it comes to graphing this polynomial. It's a sketch. So, the direction said if our multiplicity was other than 1, we needed to write it. Well, we don't have multiplicity other than 1 in this one. So, don't write anything. Now, end behavior. The end behavior is what's happening at the ends. So, here's how we describe end behavior. We say, as x approaches, we draw a little arrow. As x approaches negative infinity, that is to the left, as I move to the left on my graph, what is the graph doing? It's going up. As x approaches negative infinity, y approaches positive infinity. That's how you write end behavior. It's all about the x's and the y's at the ends, where the arrowheads are. All right, on the right side of this graph, as x approaches positive infinity, what is the y? What are the y values doing? Going up. So y approaches positive infinity. That's how you write end behavior. It's all about x's and y's at the ends, where the arrowheads are. So this little arrow, it stands for approaches. X is approaching negative infinity as y approaches positive infinity. Okay, let's look at number 2. Again, we have multiplicity of 1 for all of these zeros, so we don't have to do anything with multiplicity. So that means our curve is going to go straight through all of these points. Straight through them. So let's write the points. Negative 3, negative 2, 1. Again, you don't have to equally space them because it's a sketch. All right, so we know that since this is third degree with a negative leading coefficient, it's going to face like this. Yes. All right? So when we write that, and we know our lines are going straight through, on the left side it's going to look like this. On the right side it's going to look like this. Straight through. The left side is going up, the right side's going down. Now, I have to draw my curves. Go straight through the negative 2 and curve. So there you go. Now, what does that curve look like, kind of, compared to our graphs over there? What function? Cubic. It looks kind of like a cubic. It's got the twist in there. All right. End behavior. End behavior. Our end behavior is as x approaches negative infinity, y approaches what?
Infinity.
It's going up. Positive infinity. And then as x approaches positive infinity, y approaches what? Negative infinity. Very good. Because it's going down. All right, let's look at the next one. Let's go ahead and list our zeros. The zeros are negative 4, negative 1, 0, and 2. All right. Now, again, multiplicity is 1 for each of these zeros, so you don't need to worry about it other than to know that the curve is going to go straight through every one of those points. All right. Our degree is 4th. Our leading coefficient is negative. So what does that tell us about the way these ends face?
They're going to go down.
Both down. Exactly right. So if they're both down, go ahead and draw them as both down. Both down. All right. Now, then I have to curve and go through each of these points. Okay, so it comes out looking like an M. But I did not twist through those points. I went straight through those points, like a line does. All right, end behavior. As x approaches negative infinity, because I'll go to the left first, y approaches what? What's the y value doing? Going down to negative infinity. All right, as x approaches positive infinity, what is the y value doing? Negative infinity. Okay? So far so good. All right, let's go on to number 4. All right, in number 4, let's go ahead and draw plot our zeros at -3 and 2. Again, doesn't have to be perfectly spaced or anything. Just do it such that it makes sense to where you can do your graph neatly. All right, we've got third degree, and we've got a positive leading coefficient. So what are my ends going to be doing? Yep. All right, Jim. All right. Up to the right, down to the left. Now, we do have some multiplicity here. For the 2, we've got second degree multiplicity, which means it's going to be like a parabola. It's going to bounce. So, on the right side, it's going up, right?
No, it should be going up on one side.
Well, it's a positive leading coefficient. It's third degree, so it should be like this, right?
Yeah.
Yes.
Okay. So on the 2, I know that it's going to be doing this. Okay? I know it's going to be curving up like a parabola. On the left side, we've got first degree multiplicity, so it goes straight through it. Like a line. Alright, so from this straight line here, I'm going to curve it, and then it's going to bounce and go back up. Alright, so you got to have the curves in there, or you wouldn't be able to get to the other points, right? So you're going to have curves, but the tricky thing is knowing if it's going to go straight through the point, or bounce off the point, or do the squiggly through the point. Alright, so we did have multiplicity, so we need to indicate that. And here's how I want you to do it. I want you to say, for the 2 is the one that had multiplicity. Write 2/2. The first number stands for the 0. The second number is going to stand for the multiplicity. Okay? First number is going to stand for the 0. The second one's going to stand for the multiplicity. That's just how I want you to do it. Okay? Alright, what about end behavior? As x approaches negative infinity, notice we always start with x approaches negative infinity. What is the y doing? Negative infinity. And then x approaches positive infinity. What is the y doing? It's going up, right? Positive infinity. All right, next problem. Okay, let's go ahead and plot our zeros. Zeros are -1 and 0. Okay. Now, the -1 has a multiplicity of what?
5.
No.
No. Wait, my bad.
What's the exponent? 3. All right. The 0 has a multiplicity of what? 2. Okay, so we listed our multiplicities down at the bottom. Okay. Now, we know that if it has multiplicity 3, it does the little squiggly. Alright, and we know if it has multiplicity 2, then it looks like a parabola. And we know that this is 5th degree. And it's a negative sign.
Wait, how do you just like it? Oh, it's like that.
Are we going to need somewhere to
Alright.
You know?
Yeah, D-Berry Baptist Church. So it's going to do like this.
Oh, I was looking at you.
Alright, so the -1 is going to have the squiggly. So here's how it should be. you're going to come down, curve down through it, and then come out. Now, that's not great drawing. Okay? That's ugly. So I'm going to do a little squiggly right there, just so I know that you know that you know that I know what you're doing. All right? And then I've got to curve up. And I went a little bit too far. Whoops. Because I can't curve now. I got to bounce it. Just disregard this little part right here. Disregard that part right there. Okay, so that's kind of how this looks. So in behavior, as x approaches negative infinity, y approaches positive infinity. As x approaches positive infinity, y approaches what? Negative infinity. Okay? All right, look at the last one. Okay. This is a 6th degree polynomial. So what is my graph going to do if the leading coefficient is negative? 6th degree, what's it going to do? Going to go both down. Okay? So let's list the zeros. We got negative 3. We got positive 1. Alright? Now the negative 3 has a multiplicity of 5. So that's going to look like the cubic. And we know that both of them go down. So start down and curve up through it. Now if you want to put the little squiggly there, just so we know. Okay, now the 1 has a multiplicity of 1. So it's going to curve around and go straight down through it. So it looks like you just took your line and you just hit it on the left side and dented it in. Took your curve and dented it in a little bit. So this is, we didn't write our multiplicity. The negative 3 has a multiplicity of 5. And the 1 don't have to worry about because it has a multiplicity of 1. In behavior, as x approaches negative infinity, what does y approach? Negative infinity. And as x approaches positive infinity, y approaches negative infinity. Okay, so now what we've discussed today is how to graph from a polynomial function. Next week we're going to learn how to take a polynomial function and graph it. Okay, so I said that wrong. Today, we learn how to graph from a polynomial. Next week, we're going to learn how to go from the graph and write the polynomial of least degree. Okay.
Good Lord.
Can we go run to the bathroom?